Number 1A says write an algebraic expression for the problem that says the diameter D decreased by 6 meters. So we have a diameter, we're going to use the letter D, and it's going to be decreased by 6 meters. We need to write an algebraic expression for that. So decrease means that we're going to be subtracting, so the answer for that one is D minus 6. 1B says 3 less than twice M. So on this one we have to think a little bit backwards. This is 3 less than twice of M. So we have to think a little bit backwards. Less than, a lot of people would think that that's going to be 3 minus 2M because it says twice, meaning 2 times. But this is wrong, because less than means less than what? It means less than this. So this part right here has to go first before we can do the subtraction of 3 right here. So this is backwards. And remember, subtraction cannot be done in both directions. It is not, there is no associative property that goes with subtraction. So order does matter. So the answer on this one is 2M minus 3. So again, twice of M less than 3. So it's going to go backwards. Number 2A wants us to write an expression expressing cents in dimes, and the dimes is in dimes. So again, you have to use the N. Well, we know that dimes is 10 cents each. So if I want to know how many cents are in so many dimes, if I have 1 dime, that's going to be 10 cents times 1. If I have 2 dimes, that's going to be 10 cents times 2. So the expression for this one is 10N. So 10 cents for each dime, and then N represents however many dimes we're going to have. Number 2B wants us to express 6% commission of Y dollars. Commission is something that somebody gets a percentage of sales, and that's how they get paid. So this person's going to receive 6% commission for every dollar sold. So, as I said, we have this word here of. Of means to multiply. So we're going to have 6% of Y dollars. Again, Y meaning multiply, but again, 6% is a percent. We can't use percent as it's written, so 6% needs to be changed into a decimal, which is 0.06, of meaning to multiply. So we're going to take that and multiply it by Y. So again, expression for 6% of commission of Y dollars is 0.06Y. Number 3A asks to write an expression for the 2 unknown values. 3A says $160 is shared between John and Sally. So this is going to be 2 unknowns. We don't know what John is going to have, so we're going to have him maybe be X. Sally, we don't know what she's going to have either. But we do know that the 2 of them have to share $160. So that means that X plus Y has to equal $160. Okay? So if this represents John and this represents Sally, again, the 2 of them have to add up to $160. But when it comes to algebra, we can't have an expression with 2 different variables. They have to be written in the same variable. Well, John here is X. But how could I solve for Y? I need this to be in a different form. I need this to have an X value here. So, really, if I take how much John has away from the total, that will tell me how much Sally has. So let's say, for example, John only has $40. Well, how much do we know Sally is going to have? Well, Sally is going to have $160 minus the $40. So then Sally would have $120. So in order to write Sally in the same terms as X, we need to take the total amount, which is $160, and subtract what John has. So Sally we can sit here and substitute that in, that's going to be $160 minus X. That's how we're going to find Sally's part of this. Okay? So the two expressions that we would use to work this problem out would be X and 160 minus X. And we would need both of those. Because is this a true statement? If I have X for John and then 160 minus X for Sally, we notice what happens. The X and the negative X end up doing what? Subtracting. And so therefore I get my true statement of 160 equals 160. So these two things do represent the same thing. This is John, this is Sally. Again, you could have put them backwards. Sally could be X and John could be the 160 minus X. It doesn't matter. Either one would work. 3B has to do with two different people, Hilda and Harvey. The problem says Hilda invested 19 more than twice the amount Harvey invested in a retirement account. So we're going to be talking about Hilda first. So Hilda says that she invested $19 more than twice Harvey. Okay, so we could use J here if we wanted to for Hilda. You can use whatever variables you want to. There's no given variables, so we're okay. So this one says Hilda invested 19 more meaning plus, more than twice Harvey. So twice meaning 2 times however much Harvey invested. But we don't know what Harvey invested. So if we want to use H for Harvey, that's fine. So we could say H equals X. Or you could say just H for Harvey. Okay, so Hilda invested 19 more than twice Harvey. So here we could say 2 times X, because the more than, again, means go second. More than what? We have to start here with the twice than Harvey here. Okay, so Harvey is X, so 2 times how much Harvey spent, but 19 more than that. So plus 19. So these are the two different expressions you should have for 3B. Harvey is the one that we don't know, but Hilda invested 2 times plus $19 more than Harvey. Problem number 4 has to do with the truck rental company. There are 2 different truck rental companies that we're going to be talking about. So it says that one rental plan is $78 per day. Okay. It says then plus 12 cents per mile. Okay. It says the other plan offers no daily fee, so this is a 0. Okay, they don't offer any charge per day, but they're going to charge you 36 cents per mile. Okay, so those are the two. The breakdown for the first company and the second company. It says, determine the number of miles that must be driven in one day for both plans to cost the same. So, if the cost is the same, that means the cost of company A has to equal the cost of company B. So, once I find the expression for cost of A and the expression for B, I can set those two equal to each other, and then we need to find out how many miles that's going to be that the two companies are going to be the same. So, part A, the cost for part A is $78 per day. And the question says, determine the number of miles that must be driven in one day to be the same. So I don't need to multiply this by a variable because we're just saying one day. So $78 times 1 is just going to be $78. But company A says that they're also going to charge 12 cents per mile. So we need to write that as a decimal. So 12 cents is 0.12. But it says per mile. Do we know how many miles we're going to drive? No, that's our unknown value or unknown variable. So you could use X there. You could use M for miles. It's completely up to you. Okay? So that is our expression for cost of Company A. Company B, again, there was no daily charge, but there was a charge of 36 cents per mile. And we can use X on that one because, again, a mile is a mile is a mile. We don't have to use a different variable for miles. Okay? So we need to solve this equation for X. We look at it. Is the left hand simplified? Yes. Right hand simplified? Yes. Any parentheses? No. But do we need to put the X or the variable onto one side of the equation? And the answer to that question is yes. So we need to subtract the 0.12x to the other side. The x's cancel. 78 comes down. Okay. I subtract and I get 24 cents per mile. I divide both sides by 0.24 because, again, that's the opposite of the multiplication that is going on right next to the x. And then with my fancy dancy calculator, okay, so when we divide that, we get 325 miles. Make sure that you label that MI, not M, because M is for meters. So that means that we'd have to drive 325 miles using Company A and Company B to be charged the same amount. If that mileage were different, again, the cost would not be the same. Okay, number 5 talks about a 2009 budget being $12,600. It says that this was an increase of 5% over the 2008 budget. So the wording of this second sentence in the word problem is very, very important. It says this. This meaning what? This meaning this budget, the 2009 budget, so the $12,600 was. What does the word was mean? Was means equals. So the $12,600 was an 8% or was an increase. Increase meaning that it went up from the original, was added on a certain amount to get that increase. Right? So to have an increase, we have to take the original amount and add something else onto it. So it says that it was an increase of, again, of meaning multiply, 5%. So 5% of what? So that's the question. 5% of what? 5% of the what? Original budget. So this is 5% of the original budget. Okay? So if I take the original budget and I multiply it by 5%, that's going to give us the increase here. Okay? So we don't know what the original amount is. We have no idea what the original budget was because it doesn't tell us that number. Okay, so we're going to have the 12,000. Our original budget is going to be our variable, our X. We don't know what the original budget was. But I still need to find out how much to increase it by. Again, it was increased by 5%. 5% as a decimal is 0.05. But remember, that's 5% of what? You should be asking yourself always when you're working with a percent problem. 5% of what? So 5% of the original budget. Since the original budget is X, that means that the increase part is going to be 0.05x. Okay, so we go back to our original problem. Let's rewrite this so that it's all nice and pretty. We have 12,600x plus 0.05x. Okay, so we need to find out what the original budget here in the problem is, so we're going to have to solve for x. Well, is the left-hand side simplified? Yes. is the right-hand side simplified? And the answer to that question is no. We need to combine that 1x with the 0.05x. Now, some people would have problems with, well, I don't know how to combine that correctly, but really this is 1.0x here. Remember, there's an invisible 1 in front of every variable. So when we combine those, we get 1.05x on the right-hand side. The 12,600 is going to stay the same on the left. So to solve for x, I need to divide by 1.05, because again, there's multiplication going on right here. The opposite is division. And when I divide that, I will get my answer. Okay, so our answer is $12,000. Okay, does that answer make sense? Yes, because the 2009 budget was so the 2008 budget was increased in 2009, so therefore the 2008 budget should be smaller than the 2009 budget, so that does make sense.